Hi, in this video, I'm going to teach you how to read the cardiac pressure volume loops in under 1 minute. Now, before we see the actual graph, let's familiarize ourselves with certain terms. PV loops show the performance of the heart. This performance depends on two factors, preload and contractility. Preload is the amount of blood received by the atria. Contractility is the ability of the heart muscle to contract. Now let's simplify this further. If atria get 10 units of blood, this is just for example, then your preload is 10 units. Now when you're getting something for free, you want all of it. So your end diastolic volume will also be 10 units. End diastolic volume is directly proportional to your preload. Now that the ventricle has taken everything, it has to give some blood to the body and keep some reserve. The reserve is your end systolic volume. Let's say it's 4 units. So the difference between your end diastolic volume and end systolic volume is the stroke volume, and out here it is 6 units. Ejection fraction is the proportion of blood supplied to the body. And how do we calculate it? Stroke volume upon your total, that is your end diastolic volume. It's going to be around 60%. Now let's look at our graph. We have pressure on the y-axis and volume on the x-axis. Looking at the values, you can make out that this is for the left ventricle. For better understanding of the graph, I would advise you to see my earlier videos on cardiac cycle and Vickers diagram. Now, we will start at the lowest volume. When is there the least amount of blood present in the ventricle? That is your end systolic volume. So we start with our contractility curve. It's here. And at the end of systole, which valve will open? Your mitral valve will open. And this is followed by a phase of ventricular filling. An increase in the volume up to maximum, that's your end diastolic volume. This is when your mitral valves will close, followed by a phase of isovolumetric contraction with rapid increase in pressure and no change in volume. And this will eventually result in opening of your aortic valves, followed by ejection of blood into the aorta, which is represented by this curve, rapid and reduced ejection. This line represents your stroke volume. And then when the pressure in the ventricle will drop, your aortic valves will close, followed by a phase of isovolumetric relaxation. No change in your volume, but the pressure in the ventricle will rapidly drop. And we can mark our heart sounds, S1 and S2. And this is the systolic phase and this is the diastolic phase. Now that you know how to read the graph, can you look at this graph and identify the point where the aortic valves will close in this graph? I hope you have not answered A. The correct answer here is C. Because if you see, the first rule when you're reading a graph is look at the x and the y-axis. Out here I have reversed. The volume is on the y-axis and pressure is on the x-axis. Makes no difference. We'll start with the lowest volume, where your mitral valve will open, and fill out our valvular events like this. Okay, the second question. Which is the phase of maximum oxygen consumption? Yes, it is the phase of isovolumetric contraction. Thirdly, which point represents the maximum work done? Now, your basic formula for work in your elementary physics is force into distance. So even though maximum force is applied during isovolumetric contraction, but the distance moved by the blood is 0. So work done is 0. Maximum work is done here in the stroke volume phase. Now, can you calculate your stroke volume by this graph? Yes, we can, by putting the values in the formulas. We can also calculate our ejection fraction. Now, let us look at some pathologies. Let's start with aortic insufficiency. Now, we'll always start when we are doing these graphs, we'll always start with your basics. So in aortic insufficiency, the preload increases because your ventricles are receiving blood from the atria and some amount of blood in the aorta. So your end diastolic volume will increase because end diastolic volume is directly proportional to preload. And once your end diastolic volume increases, the heart increases the contractility to compensate to keep your end systolic volume same. What will happen to the stroke volume? It will increase. Now let's look at aortic stenosis. What happens during aortic stenosis? Your preload is the same. So your end diastolic volume will be the same. But contractility will increase because the ventricle has to pump against the resistant stenosed valve. So the loop will be taller. And in the initial phases, there will not be much change in end systolic volume. However, as time goes by and the contractility keeps increasing, contractility is inversely proportional to your end systolic volume. So your end systolic volume will also reduce. Okay, what will happen to the PV loop in heart failure? So we know in heart failure, your preload increases. So your end diastolic volume will increase. Also, the contractility has reduced. The contractility is reduced. And with the result, your end systolic volume will also increase. The whole loop will shift towards the right. Now, let's put our understanding to practice. Try solving this question and also draw the PV loops for mitral stenosis and mitral insufficiency. The solutions are given in the comments. I hope this video was helpful. Thank you.